This is a quick lesson on how to find horizontal asymptotes. There's a pretty easy trick for finding these. Just remember what a horizontal asymptote is. It is a horizontal line that a graph will approach but never actually reach. We look at equations that have horizontal asymptotes. We look at rational functions. And what we're going to do is we're going to look at the degree of the numerator and the degree of the denominator, and we're going to compare the two. For example, if I have a problem that's 3x squared plus 9 over 4x to the third plus 2x, the degree of the numerator is 2. And what we do to find that is we look at the largest exponent in the numerator, in this case 2, and that would make the degree 2. The degree of the denominator is 3. Again, look for the largest exponent used in the denominator, in this case 3. And we're going to compare those two numbers. Now, so let's see how that comparison works and how it's used to determine the horizontal asymptote for the number. Let me clear this. I'm going to bring up another problem. Okay, let's look at this problem right here. So my first step in looking at this problem is to determine the degree of the numerator and the denominator, as we were just talking about. In this case, the degree of the numerator would be 3, because we have a 3 right here, and this x is only a 1, and then 1 has no exponent, no variable with an exponent with it. So the degree of the numerator is 3. The denominator's degree is 2. The largest exponent in the denominator is 2. Now here's our first rule, or our trick we're going to use to find the horizontal asymptote. If the degree of the numerator is greater than the denominator, as it is in this case, because 3 is greater than 2, and because that is true, we have no horizontal asymptote. So every equation will not always have a horizontal asymptote. I'm going to abbreviate horizontal here. So this one has no horizontal asymptote. It has none, we might say, in a problem. Okay, now let's take another look. Anytime the numerator is bigger than the denominator, remember that's none. There is no horizontal asymptote. Okay, I'm going to put another one up. This problem. This time the numerator has a degree of 1, only a single exponent right here, and the denominator has a degree of 2, because the largest exponent in the denominator is 2. When the degree of the denominator is greater than the degree of the numerator, as it is here, 2 is greater than 1. When that's true, then this function has a horizontal asymptote of y equals 0. It will always be 0 when the denominator's degree is bigger. This function has a limit, we say, of 0. Its graph has a horizontal asymptote, y equals 0. In fact, the horizontal asymptote, that means, is the x-axis if we draw that graph. And let's look at the final case, and that would be the case where they're the same. Notice here that the numerator is 2. The degree of the numerator is 2. The degree of the denominator is also 2. So this time the degree of the numerator and the denominator are the same. 2 is equal to 2. This is the only one where we have to do any work at all. In order to find the horizontal asymptote here, we simply take the leading coefficient of the numerator. Now remember, the lead coefficient is the number in front of the variable with the largest exponent. So you have to be sure and put those at least in order where the biggest one is first. In this case it's 6. And you take that leading coefficient of the numerator and you divide it by the lead coefficient in the denominator. So y in this case is equal to 6 divided by 2, and that's equal to 3. Therefore, our horizontal asymptote is y equals 3. It would be that line that we would draw at y equals 3. Remember, it's the leading coefficient of the numerator divided by the leading coefficient of the denominator. So you have three possibilities. Either the degree of the numerator is greater, in which case there is no limit and the graph has no horizontal asymptote, or the degree of the denominator is greater, in which case the limit is 0 and the graph has a horizontal asymptote of y equals 0, or the third case, the one we're looking at right in front of you, the degree of the numerator and the denominator are the same, in which case you use only the leading coefficient, the number in front of the variable with the largest exponent in both the numerator and denominator, and you divide the lead coefficient of the numerator divided by the lead coefficient of the denominator, and that will give you the y equals line, in this case 3, that will be our horizontal asymptote. And that's pretty much all there is to finding horizontal asymptotes. Just follow that little trick each time, looking at the numerator and the denominator and finding out what the degree of each is and comparing them.